This conference will now be recorded.
Very good evening, students. Today we are continuing with the revision of electrostatic chapters. Here we are collecting the JEE advanced questions from previous papers and try to solve. So I have picked up few questions for today. Let us discuss those things. So the first question says charges Q, 2Q, 4Q are uniformly distributed in three dielectric solid spheres 1, 2 and 3 of radii r by 2, r and 2 r respectively, as you see in this figure. So this is the first sphere, sphere 1, which has radius r by 2, this, and Q, charge Q is distributed over this sphere uniformly. Second sphere is this one, having radius r. 2Q charge is distributed all over the sphere, and this is sphere 3. 4Q charge is distributed all over the sphere, and this has radius 2r. Now the question is, if the magnitude of the electric fields at point P at a distance r from the center of spheres 1, 2 and 3 are E1, E2 and E3 respectively, then which among these four options is correct? That you have to find out. So first of all, these spheres are dielectric sphere, the solid sphere. That means these spheres are non-conducting. That means they have no free charges. Okay, all the charges are bound charge within the solid sphere. Okay, and charge can reside inside since it is solid non-conducting sphere. Okay, as well as on the surface. So now, since it is non-conducting sphere, so the charge will be distributed inside uniformly, having uniform density over, like all over within the spheres. One thing you can see, the electric fields for this is E1, for this is E2, and this is E3 at the point P. P is the point for this sphere 1. It is the outside point. This is on the surface. So for the sphere 2, this P point is on the surface, and for the sphere 3, it is actually inner point. That means if I apply Gauss's law, to find out electric field, see, the general formula is like this: E for a sphere at least 4 pi r square having radius. So sphere of radius r is charge enclosed by epsilon or epsilon naught. In this case, we can write epsilon, no problem. So we have to just see which one by magnitude, which one is greater. Okay, so in this case, we can write further E is equal to K Q enclosed by r square, where K is 1 by 4 pi epsilon. This is the constant. Okay, K. Now look this sphere. For this particular sphere, we can directly write E1 is equal to 4 pi epsilon naught. P is a point r distance away from the center. So I can write this I have taken epsilon. So this is the one. So I can write k q by r square. Okay, this I can write. So what about E2? Similarly for E2 also, it has radius r and the point is on the surface. So I can just write the charge enclosed to be 2q k2q by r square. That means it is 2kq by r square. That means it is, it is 2 into u1. I can write. What about E3? E3 I can write charge enclosed k by r square. Here actually we have to see the radius of the Gaussian surface is r. So this is fine. Now we have to find out charge enclosed. Let us say Q3. This is actually, see, the 4q charge is distributed all over the sphere uniformly. So I have to find out Q3, enclosed Q3. So that is actually rho 3 into 4 by 3 pi r cube, right? So this is the one we have to find out. What is rho 3? Rho 3 is 4q divided by 4 pi, 4 by 3 pi charge per unit volume. This has radius 2r, right? So what we can get from here is, this is 4q into 3 divided by 4 pi, and here again 4. This is r square, sorry, this is r cube. So it is 8, and this is r cube. Okay, so this will be 2, this will be 2 pi. I'm sorry, there is just a mistake. Let us not worry about this. Let us just stack this 4 with this 4. So what we'll get actually, this 3q by 8 pi r cube, 8 pi r cube. If we just put it here in place of rho 3, let us see what we get. So we get rho 3. So we'll be getting here, better we could write directly this itself. Let us, without any further simplification, we'll write this itself. So pi r cube means 2r, that is 8 into r cube. Let us put it here in place of rho 3. So q3 will be 4q into 4 by 3 pi r cube. Here it is 4 pi by 3 into 8 r cube. This gets cancelled. So here it will be actually q by 2. Okay, q by 2. So if I write here in place of charge enclosed q by 2, then it is actually kq by 2 r square. Okay, so look, this is actually less than even E1. Okay, so what we get here actually, see, E2 is the greatest, then E1, then E3. So this is the sequence. Let us see if we have. Yes, the C is the correct option for this question. Okay. Now let us go to the next question. This is a really very interesting problem. Let us solve this problem. We will just look this question itself and the figure itself very nicely. A parallel plate capacitor having plate of area S, as you see here. You just think these are two plates. Okay, these are two plates. This is another plate. You can think these two are plates. Okay, having area of cross section A and separated by distance d, as you see. So it has this parallel plate capacitor, like they have plate area S and distance d, and if you have air in between, then the capacitance is C1. And what we can write for this? Epsilon 0 S by d. This is C1, right? Okay, now let us see. When two dielectrics of different relative permittivities, epsilon 1 is equal to 2, epsilon 2 is equal to 4, are introduced between two plates as shown in the figure. You look over here. See, halfway, up to halfway and half area and halfway, half distance d, half distance and half area is covered by this particular dielectric material, which is shown over here by E2. Okay, I'll just clean everything and show you once again. If I just draw simple diagram like this, so S is the area, right? So if you just divide this much will be S by 2, right? And according to this figure, see, if I divide even this, so you have D by 2. So this portion is actually filled with a dielectric material having relative permittivity epsilon 2, and all these three places, this place, this place, it is filled with epsilon 1, as you see here. See, in this case, you know, this, you look, this is positive, this is negative. That means when I have this separation, if I just take this, let me clean it, then in this case, when this epsilon 2 is introduced, this half area and half thick, okay, half of the space in between the plate, this is epsilon 2 and all over epsilon 1, then the capacitance is becoming C2. Now you have to find out the ratio. The question is find out the ratio C2 by C1. Okay, this is the question you have to solve. Okay, so look, in this case, if I just think that this is totally one half and this is another half. If I think that and see, these are the charging ports, then this this part and this part, this is D by 2, another D by 2 is this part, and this is S by 2, and this portion, this particular portion, this is S by 2, and this is actually D, thickness is D with E1. So this is very simple to find out, right? Now one point is there, is that these two guys have the potential same as these two. Okay, whereas see, if I say the potential difference between these two plates is V, Then this particular portion has potential difference V, but these are actually divided, V1 plus V2. That means these two guys are actually in series. If I draw equivalent circuit for this particular geometry, see, I have now three capacitors to say this. Let us say this is C prime, this is C double prime, and this is C triple prime. Okay, so these are three capacitor now. See, having capacitance C prime of this one. Suppose this one has, this particular portion has C prime, this particular portion has C double prime, and this particular portion has C triple prime. Okay, I'll go to the next page and draw the same figure. Okay, let me draw this. So this portion has capacitance C triple prime say, and here the dielectric permeability, relative permeability, and this portion has dielectric permittivity, relative dielectric permittivity is epsilon 2, and this is thickness d by 2. This is thickness d by 2. Okay, and this has thickness d, and this portion also has uh, dielectric permittivity, relative dielectric permittivity epsilon 1, and this has thickness d by 2, and this is s by 2, and this is another s by 2. Okay, area of the plate. And see the charging ports, if I give this way positive and this is negative, then so this one has, as I said, this is having, suppose, capacitance C prime, this has C double prime, and this is C triple prime as I have written. Now we are just finding out what is C prime. Then C prime, see, I have here equivalent diagram. C prime and C double prime, they are in series and parallel with the C triple prime. This is the equivalent circuit diagram. So I'm just calculating one by one what is C prime. C prime, see, we know when there is dielectric material inside, so we'll write, if suppose it is epsilon r, then we write what we write, epsilon 0 epsilon r, area by distance between the plate. This is what we write. So similarly here also we'll write the same thing for each of them. So C prime is this part, so it has C0 epsilon 1, this is area is s by 2, and the distance is also d by 2. So this two will get cancelled. So s epsilon 1 epsilon 0 by d, this is 1. Okay, now again in this problem, see, epsilon 1 is given as 2. I'll directly write the value. Epsilon 1 is given as 2. Epsilon 1 is 2, epsilon 2 is 4. I'll write directly here 2 is epsilon naught by d. So if I take this as some C0, if I take this as C0, then C0, what not C0 even, see, in fact, see, when it was just this one and air was there, that time capacitance according to the problem, this C1 is epsilon naught by d. Okay, epsilon naught by d. So that is there. Let us see, let us keep like this itself. Similarly, for this particular portion C double prime, it will be C2. So 4 is S0 divided by D. Now for this particular portion it is D and this is S by 2, right? So C triple prime, it is 2 epsilon 0, S is S by 2 divided by D. That means this will get cancelled, so it is S epsilon 0 by D. Okay, now look, I have got all these three. So this part is common for all of them. So this is actually 2 unit of that, this is 4 unit of that, and this is 1 unit of that. So if I just take this combination, and equivalent capacitance of this combination will be, see, 1 plus, these are actually in series, so multiplied by 6. Okay, 4 into 4, 4 plus 2, so this is the equivalent capacitance of this. So it is actually 1 plus, this is 8 by 6, so 4 by 3, that means it is 7 by 3. So equivalent capacitance, this is common anyway, this epsilon 0 by D is common, so S epsilon 0 by D along with that. Now look, this combination is actually the value of C2. So C2 is actually 7 by 3 S epsilon naught by D. And again, C1 we have seen it is S epsilon naught by D. Now if I take ratio of C2 by C1, what we get? Epsilon 0 by D, and this is S epsilon 0 by D. So this will get cancelled. Okay, this will be 7 by 3. So C2 by C1 is equal to 7 by 3. So let us see the options. So the fourth option, option D, will be correct answer for this question. Okay, I hope you have understood this. Now let us see this question. This here the question is, there are two non-conducting solid spheres of radii r and 2r, having uniform volume charge densities ρ1 and ρ2 respectively, and they touch each other. The net electric field at a distance 2r from the center of the smaller sphere along the line joining the center of the sphere is 0. Then the ratio r1 by r2 is how much? So the question is, this is one sphere having radius r, and another non-conducting sphere which has radius, which has say radius 2r. Okay, so radius 2r, they are in touch, and if I join this center C2 and this is C1, say, then the net electric field at a distance 2r from the center of the smaller sphere, the center C1, 2r distance if we see, so this is r, this is another r, so this much. I can actually have 2 points P, and in this side also there is another point Q which is at 2r distance from this. So this is 2r, and this is also, this is also 2r distance, at 2r distance from the center C1. Okay, this is one possible point, and another possible point is this one. So at these 2 points, if the net electric field is 0, then which among these four options are correct? I hope you have understood the problem. The problem is that there are two non-conducting sphere of radii r and 2r as I have drawn here. So each of them, this has uniform charge density rho 1, this has charge density rho 2. Now from the center of this smaller sphere, if I go along the line joining the centers of these two spheres, then 2r distance away from the center C1, the electric field becomes 0. Then what is the ratio of rho 1 by rho 2? So that is the question. So I can have two possible points or positions. This is 2r distance away, this point, because this is 2r. So along this is along this P is one point and Q is another point. These 2 points are on the line joining the centers, right? So we'll see if electric field at this particular position is 0, what is the ratio rho 1 by rho 2? And if at Q the electric field is 0, what is the value of this ratio rho 1 by rho 2? All right, we'll go to the next page. Oh, okay, let us see. So when, let us consider the point, consider P. So if the electric field is 0, see in this case, since these are two positive charge densities, so electric field will be in this way for the sphere 1, and electric field for this at this point will be in this direction. Okay, they will be actually opposing each other. So if electric field is 0 at P, then we can write, see electric field due to this particular charge, we can write K Q by, this is 2r, right? So 2r square, right? And this will be equal to the K, if I say this is Q1, K Q2 charge on this by, this is total 2r, this is r, so this is at r distance. Okay, all right. So in this case, you look, if I write K anyway get cancelled, so r square down will be getting cancelled, so this is Q1 by 4, and this is actually Q2 by 1. Okay, so Q1 by Q2, so Q1 by Q2 will be 4 by 1. See, I can write Q1 in place of Q1, I can write 4 by 3 pi r cube, right? R cube I can write, and in case of Q2, we can write this, since it is inner point, here also will be writing r only, not 2r. Okay, all right, into rho 1, and here we can write in place of Q2, also we can write 4 by 3 pi rq only, because this is the inner point into rho 2. So this goes up like this. So rho1 by rho2 will be 4. So this D option is correct. If electric field is 0 at P, then rho1 by rho2 will be 4. That is correct. So option D is correct. Now we'll go with the other option, that is, so other point is oh sorry, let me, okay, let us be satisfied with this. And let me just draw the smaller one like this. Okay, they're in touch, so their centers are like this. Okay, so I have here the key point. So this is 2r, this is r, this is r, and 2r from the center C1 means this is also r. So see, from the sphere to the charge, actually see electric field lines at this point due to both of them will be in this way. Okay, so they will be actually additive. So I can write if E is 0 at Q, then what we can write is, we can write K Q1 by, so this is R and R, so 2R square plus K Q2 by, this is 2R, this is 2R, 4R, this is 1R, so 5R whole square. This is equal to 0. So this I can write Q1 by 4R square, and this is Q2 by, with the minus sign, 25R square again, you can just cancel them out. Okay, now look what we can do. We can just put this Q1 and Q2 values. Okay, what is Q1? Q1 is rho 1 4 by 3 pi RQ. Okay, and what is Q2? Q2 is rho 2 4 by 3 pi 2R cube. Okay, then see, we can just do one thing here. Anyway, we have to find out rho 1 by rho 2. So Q1 by Q2 is equal to minus 4 by 25. So what is Q1 by Q2? We can just take the ratio over here. Q1 by Q2 is, so this goes off. So here rho 1, so it will be actually 1 over 8. So Q1 by Q2 is 1 over 8, and along with this there will be rho 1 by rho 2. So rho 1, so Q1 by Q2 is rho 1 by 8. This is rho 1 by 8 rho 2. So rho 1 by rho 2 will be minus 32 by 25. Okay, so this is another answer for this particular point. So option C is also correct for this question. Okay, now we'll move on to the next problem. This is very interesting. We will read out quickly. In the circuit shown in the figure, first of all, let us see the figure. So there are three switches, S1, S2, and S3, and there are two batteries having EMF 2 V0, and this has V0. and there are two parallel plate capacitors, okay, having capacitance C1 and C2. They are connected parallelly if these are connected, if all the switches are connected. Anyway, let us see. Each of them has actually capacitance C1, C2, C. So there are two parallel plate capacitors, each of capacitance C. The switch S1 is pressed first to fully charge C1. So when S1 is pressed, then C1 will be fully charged, is fully charged. So what is the charge then? Q1 will be 2C and V0. Okay, now then it is released. S1 is released. When actually S1 is closed, see S1 is closed means you get this circuit. Only C1 is connected to the battery. Okay, so this is 2V0 and this CU1, right? So it gets charged by this much. Now the switch S2 is then pressed to charge the capacitor C2. So after this, C2 is pressed and C1 is released. That means, you know, you get the equivalent circuit for this is C1 and this is C2. They will be actually connected via S2 switch here. And the batteries, see this battery is connected to S3, so S3 is not on and S1 is not on, so batteries are not connected to this circuit. So what happens? So there were actually two CV0 charges, so they will be, since they have equal capacitance C, so this charge will be actually equally distributed as long as this is, so after some time means when, see, after some time C1 and C2 both will be actually getting charged. C1 and C2 both will be getting charged by CV0 and this also CV0 because charge will be equally distributed. Now S2 is also released, then S3 is pressed. Now the third case is, see, after this configuration, now C1 and C2, so C1 is actually released, see S2 is released and S3 is closed. See, this is S3, with battery having opposite polarity. If you see the figure, this is V0 and this is the capacitor C2 and this is CU1. So this is capacitor C2, capacitor CU1. So CU1 is now opened and C2 is closed with this battery. Okay, now look this question. Then S3 is pressed. After some time, the charge on the upper plate of the CU1 is 2C V0. The charge on the upper plate after some time means after C2 is released, sorry, S1 is released and S2 was pressed. After that, S2 is released and S3 is pressed. In the sense, when the S2 is released and S2 is pressed, at that time, what is the charge? Charge on the upper plate C1 is 2CV0. That is not correct because after S2 is pressed, so these two will be actually equally distributed. So upper plate will be having CV0 charge. The charge on the upper plate of C1 is CV0. This is correct. The charge on the upper plate, I think this also will be V0 only. The upper plate of C2 is CV0. So upper plate, in this case, you look in the last case when the battery is connected in the opposite polarity, so this will get actually negative charge and this will have positive charge, but with the same CV0. Okay, so the charge on the upper plate of C2 is CV0 with a minus sign, okay, with the opposite polarity. So these two are the correct option here. Okay, so with this we'll stop it here for today. Next day we'll pick up some more problems on this chapter. We will go up to 220, sorry, 2022. So this is also actually from JEE Advanced. I hope this is 2015. This capacitor problem is from 2000. Sorry, this is from 2013. This is Advanced, JEE Advanced 2013 problem. Okay. All right. We'll like that. We'll pick up to 2022, and then we'll move on to the next chapter once we finish JEE Advanced question for this chapter till now. Okay. All right. Thank you for your patience. Bye for today.